Deep learning models are incredibly powerful. But here's the thing. One size doesn't fit all. You can't just use one kind of AI brain to solve every single problem. Some problems need sight. Others need to understand the flow of time. And some, well, they demand a really, really good memory. So today, we're going to pop open the AI specialist's toolbox and meet the different brains that power so much of the world around us. I mean, have you ever really thought about how your phone just knows it's you and unlocks instantly? Or how your smart assistant actually gets what you're saying? Or maybe even crazier, how a machine can translate a whole paragraph and somehow keep the original meaning? These are the big questions we're diving into today. First up, images. When it comes to a machine, seeing isn't about having eyes, right? It's all about crunching pixels. It's about finding patterns, objects, and yeah, even faces inside a giant grid of data, just like when your photo app automatically tags your friends. Okay, so that's images. But then you've got this whole other challenge, sequences. This is where order is everything. Think about speech. It's not just random sounds. It's a flow, a stream of information over time, and a machine has to process it one step at a time to turn it into text. And maybe the toughest nut to crack is memory. For an AI to translate a long, complicated sentence, it can't just look at one word and then the next. No way. It has to remember the context from the very beginning to have any hope of making sense of the end. All right, so here's our game plan for this explainer. We're going to start with why we even need different models. Then we'll meet our three specialists, CNNs for vision, RNNs for sequences, and their superpowered cousins, LSTMs, for memory. We'll figure out when to use each one, and then we'll get a little sneak peek at the next giant leap in AI. So the first thing to really get is that deep learning isn't some magic wand you can just wave at every problem. It's much more like a high-tech toolbox, and for each unique problem, there's a specific, powerful tool designed just for that job. I mean, think about it. You wouldn't use a hammer to saw a board in half, would you? Of course not. It's the same idea here. The way we build an AI to analyze an image is totally different from how we build one to understand a sentence. The problem itself tells you which tool you need to use. All right, let's reach into that toolbox and pull out our first tool. When a machine needs to see, when it needs to understand the visual world, it turns to the undisputed masters of vision, convolutional neural networks, or CNNs. So what exactly is a CNN? Well, it's a special kind of neural network that's just brilliantly engineered to work with data that looks like a grid, like an image. And its secret weapon is something called a filter. Okay, this slide really shows the magic behind how a CNN sees. It doesn't look at the whole picture all at once. Instead, a tiny little filter, just a small grid of numbers, slides across every single part of the image. It's looking for really simple things like edges, curves, and textures. Then, as you go deeper into the network, it starts combining those simple patterns into more complex things like an eye, then a nose, and boom, a face. And here's the really, really clever part. That one little filter, it gets reused over and over and over again across the entire image. This trick is called shared weights, and it makes CNNs incredibly efficient. It also means the network doesn't care where the pattern is. A cat in the top left corner is just as easy to spot as a cat in the bottom right. And this simple but super powerful idea, well, it's literally everywhere. It's classifying your photos, it's detecting other cars for a self-driving vehicle, it's the facial recognition that unlocks your phone, and it's even helping doctors find anomalies in medical scans. CNNs are, without a doubt, the eyes of modern AI. Okay, so CNNs are the champs for grids. But what about data, where the order of things is the most important part? For that, we need a totally different tool. Let's meet the recurrent neural network, or RNN. This is where the RNN comes in. It's built for anything that comes in a sequence. Like the words in a sentence, the price of a stock over time, or even the notes in a piece of music. Unlike a CNN that sees everything at once, an RNN works step by step, one piece at a time. The real secret sauce of an RNN is this kind of loop it has. As it reads each word, it passes along what it's learned in something called a hidden state. You can see it with that arrow there. This hidden state is like a running summary, a short-term memory of everything it's seen up to that point. Now, this little memory system is great for short stuff. But what happens when you're dealing with a really, really long paragraph or a whole conversation? Yeah, here's the catch. A basic RNN kind of has the memory of a goldfish. It's called the vanishing gradient problem, which sounds complicated, but just think of it like that game of telephone. As the message gets passed down the line, it gets weaker and weaker. By the time the RNN gets to the end of a long sentence, it might have completely forgotten what happened at the beginning. So, this whole forgetting thing was a major headache for a long time. The solution? A seriously cool upgrade to the RNN architecture, the Long Short-Term Memory Network, or LSTM for short.
LSTMs were built from the ground up to solve that memory problem. They have a more complex memory cell that has these special internal controls called gates, which act like little gatekeepers for information.
This slide is awesome because it shows you the control panel inside an LSTM. You've got these 3 gates that are basically tiny decision makers. The forget gate can decide to throw out old info that's not relevant anymore. The input gate decides what new information is important enough to keep, and the output gate figures out what part of its memory to use right now. Okay, let's put this into a real-world example. In a sentence like this, a basic RNN might get to the end and have already forgotten Mumbai, but an LSTM? It's smart. Its gates can decide to hold on to both Paris and Mumbai, understanding the full context and the feeling behind the sentence. This was a total game changer. And let me tell you, being able to remember stuff from way back in a sequence, that wasn't just a small step. It was a full-blown revolution. It's what took AI from understanding short commands to translating entire articles and having much more natural conversations. It powered everything from Google Translate to speech recognition on your phone.
Okay, so we've met our vision specialist, our sequence expert, and the memory master. Let's put it all together in a quick guide so you know which tool to grab from the toolbox.
Think of this table as your go-to cheat sheet. Simple, right? If your data is in a grid, like a picture, CNN is your answer. If the order of your data is the most important thing, you're looking at an RNN. But if that sequence is long and you need to remember things from the beginning, the LSTM is, by far, the best tool for the job. So these 3 architectures, CNNs, RNNs, and LSTMs, were absolute game changers. They really defined an entire era of AI breakthroughs. But technology never stands still, does it? Even these incredible tools started to show their limits. And this timeline really tells the story. You see the early breakthroughs with CNNs and RNNs. Then LSTMs come along and solve that huge memory problem. But then a totally new idea starts to bubble up, something called an attention mechanism, which would lead to a whole new architecture and change the game all over again. See, the problem was even LSTMs started to hit a wall with, say, an entire novel. And because they had to go step by step, word by word, training them on the massive computers we have today got really slow. The world needed a new model that could look at the whole sequence at once and just pay attention to the most important parts. And not limitation. That need for something even better is what brings us right up to the modern era of AI. It set the stage for the architecture that powers pretty much everything you hear about today, from ChatGPT to Bard. We're talking about the transformer. So there you have it. CNNs for seeing, RNNs for sequences, and LSTMs for remembering the important stuff over the long haul. Each one was a massive step forward, a brilliant tool that solved a critical problem. But even the best tools eventually inspire the creation of something new. Thank you so much for watching. We are Knowledge Equity Partners, and we're a multilingual channel where we get to share contemporary and practical knowledge on all sorts of topics that can help make your daily life more effective and efficient. If you found this valuable, we'd love it if you'd subscribe to Knowledge Equity Partners. That way you'll get notified about our daily videos. And of course, don't forget to like this video and share this knowledge with your family, friends, and your community. Let's work together to keep the quest for knowledge always high. And make sure to look out for our next episode, because we are going to do a deep dive into that revolutionary transformer architecture. You are not going to want to miss it. Thanks again for watching.